All right, before I start the new lesson for today, I want to remind you about a few things. First of all, on Monday, it's an early dismissal, so I probably will not see my 6th nor 7th period class. I will definitely see 1st, 2nd, and 3rd, and I will very briefly see 5th period. Not enough time to even cover a lesson. So just a reminder that February the 29th, which is this upcoming Monday, it is early dismissal and it's parent-teacher conferences from 6:30 to 8:30 p.m. for the high schools. From 6:30 to 8:30 p.m. from the high schools. This is going to give you a chance or an opportunity to pull for a coupon if you bring a parent or a guardian to speak to me. On Monday will be a project day for the morning classes for those that show up to school, since I won't see the afternoon classes. So Monday will definitely be another project day. Homework is due on Tuesday, so please make sure that you are working on that because it will be due on Tuesday when you come in. All right, with that said, we're going to go ahead and move on into section 2.2. For the past couple of days, we've been studying quadratics. And one thing about quadratics is that the highest exponent that you have seen or have noticed is a 2. That's the highest exponent. It also forms a U shape, which is called a parabola. But now we're going to move on into polynomial functions of higher degrees. So now you're going to see bigger exponents, 3, 4, 5, 6, 7, and so on and so forth. So please make sure, I'm going to go ahead and give you a couple of minutes to copy all of these rules down. I know it's a lot, but it's probably the last uh, bit of info that's going to be a lot. So write those down. I'm going to give you a couple of minutes and then we'll actually explain each rule. And again, well, not again, but I want to let you know that you already know these rules. You already definitely know them. You're just applying it to higher degree polynomial functions. You know them, but you really don't know that you're using them and actually know them. So write those down, and I will come back in a few minutes and start the lesson. All right, hopefully most of you all are wrapping it up. And I'm going to be going back and forth from the PowerPoint slide to the paint screen. This is very important right here. The way we read this is f of x is equal to a, x to the nth power, where n is in the set of integers. Where n is in the set of integers. A is just a coefficient, and n is an exponent. All right, so let's go ahead and start. And again, I've said that you know these already. You just probably have no idea that you know them. So let's start off with these two that I want you to consider as your foundation. I want you to consider as your foundation. Let's start off. Let me actually write the form that I just gave you. It's f of x is equal to a times x to the nth power, where n is in the set of all integers. And I'm going to give you a parent function, which you should know what it is. And it's f of x is equal to x. Now, we all know that f of x is just a fancy way of saying y. So in other words, in this case, I have y equals x. Is it in the form that is above, the generic form? Some of you all probably say yes, some of you all probably say no, but the true answer is it is. It is. Because what number, imaginary number, is in front of the x as a coefficient? 1. And this is x to what power, even though you don't see it? 1, x to the first power. So let's go ahead and match up. The n matches up with the 1 here in the exponent, and the 1 matches up with the a. So in other words, in this case, my a is 1 and my n is 1. Okay, well, let's take a look at the calculator. You should also know what the graph of f of x equals x or y equals x looks like. But for those that don't know what it looks like, I'm going to actually type it into the calculator to show you. Y equals x. All right, so it is a line with a positive slope that goes through the origin. We've seen this line before, especially in the foldable that I've made you do. So what do we notice about here? Let's focus on the quadrants. This is a line that starts and ends in quadrants 1 and 3. Let's write that down. 1 and 3. I'm going to write it here to the side. 1 and 3. Okay. So we have quadrants 1 and 3. What can we say about A, the coefficient? Is it positive or negative? Okay, so A is positive. In other words, it's greater than 0. What can we say about N? Is it even or odd? What is the 1? Is that an even or an odd number? It's odd. So we have N is odd. All right, so we have that if A is greater than 0 and N is odd, it's going to be living in quadrants 1 and 3. Let's check which one of those rules it falls under. All right, so we have it here. If N is odd and A is greater than 0, then the function will end in quadrants 1 and 3. Does that not prove what I just typed in the calculator? Is that true? Is it in quadrants 1 and 3? Yes, that is true. All right. Okay. So let's do another one. So let me clear this out here. Let me erase this part here. I'm going to still keep up the generic equation there because we're going to always go back to it. And remember, these are foundations that I'm doing. I'm giving you equations that are foundations. And let me now say that I want to look at f of x is equal to negative 1 x to the nth power, or in other words, x to the first power. All right, well, what do you notice is the only thing that changed? N is still my exponent, and that's still 1. But this time my a is no longer 1, it's negative 1. All right, so let's plug it into the calculator. Let's just plug it into the calculator. So now we have y is equal to negative x. And let's see what that graph looks like. Okay, so it has completely flipped. Now it's in quadrant, what was in quadrant 3 is now, what was in quadrant 3 right here has been flipped and is now in quadrant 2. What was in quadrant 1 here is now flipped and is now in quadrant 4. So we are in quadrants 2 and 4. Okay, let me write those down here. Quadrants 2 and quadrant 4. All right, well, what do we notice about A? Is A positive or negative? Well, in this case, A is negative. And what do we notice about N? Is it even or odd? In this case, N is still odd. So the only thing that changed was the coefficient letter A. So what can we say about any polynomial function that has A as a negative number and n as the exponent that is odd? It will always be living, starting and ending in quadrants 2 and 4. 2 and 4. And that does confirm with the picture we just graphed on the calculator. All right, so that's the base. That is the base, or the foundation, for all of the exponents that are odd. Let me give you an example. Let me click on this next, there we go. Okay, so if n is odd and a is less than 0, in other words negative, then f of x will end in quadrants 2 and 4. That has been confirmed through our work. So now let me give you another example. So let's type in x to the 5th power. X to the 5th power, where n, the exponent, is odd, and a, the coefficient, is positive. So if we look at our rules, that's this first rule right here, and we know that it's going to start and end in quadrants 1 and 3. Let's see if that's true. It is true, quadrants 1 and 3. Okay, well, let me change it up a little bit. Let me now do, I'm still going to do an odd one. Let's do negative x to the